So next is, so after that,
We connect the circuit.
there's a circuit. Okay, this is the circuit actually. Alright, okay, so that's the source. We have the diode and the resistor. So here, this is the source,
Yes.
this is the diode, and this is the resistor.
Okay.
So here, we got the AC source. Alright,
Okay.
from this side, we have the oscilloscope. So we use two channels, huh?
Yes. Yes.
Channel 1 and 2. So as you can see, it shows the input and this shows the output. So how will you connect? So how you connect it? So the input, how you connect the input?
The input we connect it here,
Here, okay.
and the output here in the resistor.
And the resistor. So based on the drawing also, so exactly what he did. Output, yes, positive here. Aywa. Let's see the, okay, so let's see the whole picture. Alright. Okay, so after the connection now, what we get is a perfect sine wave input and a perfect half wave output. Type.
Okay. Okay.
So perfect connection.
Right now, finish.
Yeah. So now start now what? Start measuring. Measure now. Let's try to measure Esma. Measure the input by DMM first. How did you do? How will you do it? Yes.
Positive one.
Positive 1.
And the negative here.
Ayun. Ano? How much you get?
6.1.
6.05. 6.05. Right. Okay. So now, let's go to the next column, which is the oscilloscope. Input of the oscilloscope. So, based on the table, we need to get the measurements from the oscilloscope. So, as we mentioned before, where is the input here? Up one, and the output is the below one. So now the question is, how will you now calculate the input voltage based on the division? So how? So as you can see here, pick to pick, right?
Yes. Yes.
Pick to pick. So how, the question is, how many division now? Pick to pick, how many division the waveform consumes?
Yes.
One division, then more than half. So maybe 1.8 or 1.7, huh? Okay, let's make it 1.7. So division is 1.7. Okay, multiplied by what? Multiplied by what? Range, which is 10 volt. The range, right? Because we are looking at the channel 1, so is the range of the 10 volts. So that would be that division multiplied by the range, which is 10 volt, multiplied by 10 volt. So that will be equal to 17 volts. Yalla, 17 volts. Alright. So same thing with the time. So the question is, how much time did the signal travel? So from which point? Yeah, from here. I think go to this point. Move it a little bit. Aywa, alas. Okay, so the waveform complete preview is this one, right? Like this.
Yes.
Full cycle. One full cycle. So this one will be 1, 2, 3, and 3.4. 3.4. So it's 3.4. Agree? Agree?
Yes.
Agree? Again? So it's 3.4, huh?
Yes.
Right? Yalla, 3.4. Yalla, so we have 3.4. So now, multiplied by which range now? Where's the range now?
This one?
Come at the range?
5
millisecond. Put 5 millisecond. 5 millisecond. So the answer would be 3.4 times 5. 3.4 times 5. Just this one. This one. 17? 17?
Yes.
17? Okay, 17 milliseconds. Oh, almost same, huh? 17 milli.
Yes.
17 milli. Okay, 17 milliseconds. So, therefore, since we have the time, we can now calculate the frequency. Not function, frequency. Alright, so what's the frequency? Calculate 1 over time.
Sa bata.
17 milli, milli. Put milli. It's milli. Okay. Come. 58. Wow, almost 60. So it's close to 60. So that's expected, sir, because it's standard 60 hertz, sir. So it's 50 point. So expected should be closer to 60 hertz. So if that's the number, meaning your connection, the waveforms are all correct. Mabruk.
Okay.
Okay?